Namaste to everyone. I welcome you all in my YouTube video channel. Today I will deliver lecture on linear algebra chapter Eigenvalues and Eigenvectors. Lecture number 6, in which I will prove some more theorems on eigenvectors. Now we prove the next theorem. Theorem is if x is a characteristic vector of a matrix A corresponding to the characteristic value lambda, then k multiply x is also a characteristic vector of matrix A corresponding to same characteristic value lambda. Here k is any non-zero scalar. Now we prove this. Given that capital X is a characteristic vector of a matrix A corresponding to the characteristic value lambda. Therefore, Ax equal to lambda x, x not equal to 0. This is number 1. Let k is any non-zero scalar. Now we multiply both sides of 1 by k. We get k ax equal to k lambda x, implies that a kx equal to lambda kx. This is number 2. From 2 we get that since here ax equal to lambda x, then lambda is characteristic value of A and capital X is characteristic vector or eigenvector corresponding to eigenvalue lambda. Kx is a characteristic vector corresponding to here characteristic value lambda. Since x is a characteristic vector of matrix A corresponding to characteristic value lambda, therefore characteristic value corresponding to characteristic vectors x and kx be lambda. that is corresponding to same characteristic value lambda, we get more than one characteristic vector. Proved. That is, Kx is also a characteristic vector of matrix A corresponding to same characteristic value lambda. Now we prove the next theorem. Next theorem is, if X is a characteristic vector of a matrix A, then X cannot correspond to more than one characteristic values of A. Given that X is a characteristic vector of a matrix A, if possible, let X corresponds to characteristic values lambda 1 and lambda 2. Therefore, Ax equal to lambda 1 x, x not equal to 0. This is number 1. And Ax equal to lambda 2x, x not equal to 0. This is number 2. Left hand side of 1 and 2 are equal. Therefore, right side will be equal. Therefore, lambda 1 x equal to lambda 2x implies that lambda 1 x minus lambda 2x equal to 0. This is 0 vector. Implies that lambda 1 minus lambda 2 x equal to 0. This is number 3. Since x is not 0 vector, therefore from 3 we get lambda 1 minus lambda 2 is 0 number, implies that lambda 1 equal to lambda 2. Therefore, the characteristic vector x cannot correspond to different characteristic value. Proved. If we consider lambda 1 and lambda 2 different, then ultimately we get that lambda 1 equal to lambda 2. So any characteristic vector cannot correspond to more than one characteristic value. In previous theorem, we have seen that any characteristic value may correspond to more than one characteristic vector. But here we get that one characteristic vector cannot correspond to more than one characteristic value. This is very important. Here we have important note. Number one characteristic value may correspond to more than one characteristic vectors. Number two, one characteristic vector cannot correspond to more than one characteristic values. This is the set for characteristic vectors. Set. This is set for characteristic values. This is a function f. Here x1, x2, x3 xn. Here lambda 1, lambda 2, lambda 3 lambda m. Let x1 corresponds to lambda 1, x2 corresponds to lambda 1, x3 corresponds to lambda 2. Here we see that the characteristic value lambda 1 corresponds to characteristic vectors x1 and x2. That is, one characteristic value corresponds to more than one characteristic vector x1 and x2. Number one. But characteristic vector x1 corresponds to single characteristic value lambda 1, x2 corresponds to single characteristic value lambda 1, x3 corresponds to single characteristic value lambda 2, and so on. Therefore, f is many one function in which domain is the set of characteristic vectors and codomain is the set of characteristic values. Now we prove the next theorem. Next theorem is the characteristic vectors corresponding to distinct characteristic roots of a matrix is linearly independent. Let x1, x2 xm be the characteristic vectors corresponding to distinct characteristic roots lambda 1, lambda 2 lambda m of matrix A. Therefore, A xi equal to lambda I xi I equal to 1, 2 m. That this is number 1. We have to prove that x1 x2 xm are linearly independent. If possible, let x1 x2 xr x m are linearly dependent. In which x1 x2 xr are linearly independent. Therefore, if we include xr plus 1 with x1 x2 xr, we get that x1 x2 xr plus 1 are linearly dependent. Therefore, for some ai not equal to 0, a1 x1 plus a2 x2 plus plus ar xr plus ar plus 1 xr plus 1 equal to 0. This is the definition of linearly dependent for some ai not equal to 0. Let this is number 2, implies that a, we multiply this, a1 x1 plus a2 x2 plus plus ar xr plus ar plus 1 x r plus 1 equal to a multiply 0 matrix. This is 0 matrix, implies that a1 a x1 plus a2 a x2 plus plus ar a xr plus ar plus 1 a xr plus 1 equal to a multiply 0 matrix is 0 matrix, implies that a x1 equal to lambda 1 x1, a1 lambda 1 x1 plus a2 ax2 is lambda 2 x2 plus plus ar lambda r xr plus ar plus 1 lambda r plus 1 xr plus 1 equal to 0. This is number 3. Multiplying both sides of 2 by lambda r plus 1 and then subtracting from 3, we get a1 lambda 1 and here we have multiplied by lambda r plus 1. So this minus lambda r plus 1 x1 plus a2 lambda 2 minus lambda r plus 1 lambda r plus 1 x2 plus dot 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 plus ar lambda r minus lambda r plus 1 xr plus ar plus 1 here lambda r plus 1 minus here we have multiplied by lambda r plus 1 lambda r plus 1 xr plus 1 equal to 0 implies that a1 lambda 1 minus lambda r plus 1 x1 plus a2 lambda 2 minus lambda r plus 1 x2 plus dot 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 plus ar lambda r minus lambda r plus 1 xr equal to 0 matrix. This part is 0 lambda r plus 1 minus lambda r plus 1 0. This is number 4. Since we have assumed that x1 x2 dot 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 xr are linearly independent and lambda 1 lambda 2 dot 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 lambda r plus 1 are distinct. Therefore a1 coefficients will be 0. a1 lambda 1 minus lambda r plus 1 equal to 0. a2 lambda 2 minus lambda r plus 1 equal to 0, comma dot 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 comma ar lambda r minus lambda r plus 1 equal to 0. This is number 5. Since lambda 1 not equal to lambda r plus 1 implies that lambda 1 minus lambda r plus 1 not equal to 0. Similarly, lambda 2 minus lambda r plus 1 not equal to 0, comma dot 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 lambda r minus lambda r plus 1 not equal to 0. Therefore, from 5 a1 equal to a2 equal to dot 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 equal to ar equal to 0. This is number 6. This is not equal to 0 means a1 equal to 0. This is not equal to 0 means a2 equal to 0. And similarly, this is not equal to 0 means ar equal to 0. Using 6 in 2, we get a1 x1. a1 means 0 x1 plus a2 0 x2 plus dot 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 plus ar 0 xr plus ar plus 1 xr plus 1 equal to 0 implies that ar plus 1 xr plus 1 equal to 0 implies that ar plus 1 equal to 0, since xr plus 1 not equal to 0 vector. This is number 7. Therefore, using 6 and 7 into, we get a1 x1 plus a2 x2 plus dot 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 plus ar xr plus ar plus 1 xr plus 1 equal to 0 implies that a1 equal to a2 equal to dot 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 ar plus 1 equal to 0. Therefore, x1, x2, dot 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 xr plus 1 are linearly independent. Which is against our assumption. x1, x2, dot 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 xr plus 1 are linearly dependent. So, our assumption x1, x2, dot 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 xm are linearly dependent is wrong. Therefore, x1, x2, dot 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 xm are linearly independent. Proved. Thanks for watching my video. If you are satisfied with my presentation and contents, then please click on like button. And if you have not yet subscribed my YouTube channel, then please subscribe my YouTube channel. Thank you.